Hello everyone, in this video we are going to discuss about uniform distribution. So now we'll discuss some problems on uniform distribution. We'll say the first one. If x is uniformly distributed with mean 1 and variance 4 by 3, find probability of x less than 0. So now as discussed, mean is given by b plus a plus b by 2. Which is equal to given as 1. So this imply a plus b is equal to 2 and variance is given by b minus a whole square by 12 and this value is given by 4 by 3. On simplifying, that is if we cancel the terms and simplifying, we will have this as b minus a whole square is equal to 16, that is b minus a is equal to plus or minus 4. Now I will take this as 1 and this as 2. Now solving this 1 and 2, we get the values of what? So solving 1 and 2, that is we will take a plus b is equal to 2 and from second equation we can write it as what? Minus a plus b is equal to 4. So simplifying, this imply b is equal to 2b is equal to 6, that is b is equal to 3. And since b is equal to 3, now we will use this and find out the value of a. So from 1, we have a plus b is equal to 2. Now simplifying here, a plus 3 is equal to 2, imply a is equal to 2 minus 3, which is equal to minus 1. And we know that a value should be always less than b. So what we have, the value of a is equal to minus 1 and b is equal to 3 and a is less than b. Now we will write down the distribution first. So what is the probability the probability distribution function is now given by f of x is equal to 1 by b minus a, that is 1 by 3 plus 1, which is equal to 1 by 4 between interval 0 and between interval minus 1 and 3, minus 1 less than x less than 3 and 0 elsewhere. Right. So since the uniform distribution is given by 1 by b minus a, here b value is 3 and a value is minus 1. So we will have 1 by 3 plus 1, which is equal to 1 by 4. So f of x is equal to 1 by 4 between interval minus 1 to 3, that is a less than x less than b. So what we have seen that already f of x is given by 1 by b minus a between interval a less than x less than b and 0 remaining, right, otherwise. So based on this form we have written the distribution function f of x. Now after writing the distribution function we will find probability of x less than 0. Now he asked you to find the probability of x less than 0. So probability of x less than 0 is given by, so here when we see the interval, it is defined between minus 1 and 3. So what will be the lower limit? Less than 0 means lower limit will be 1 and upper limit will be 0. F of x right. Now this will be equal to minus 1 to 0. And what is f of x? 1 by 4. So 1 by 4 dx. Now integrating what we have, so this is equal to 1 by 4 and we know that integral of 1 is x with respect to x. So x between limits minus 1 and 0. So this is equal to 1 by 4 and if I substitute the upper limit and lower limit, we'll have this as 0 and lower limit is minus 1. So minus and minus will become plus. So 1 by 4 is equal to 1 by 4. Now we'll look into one more example. First let us see what is the given question. The thickness of a protective coating applied to a conductor follows a uniform distribution over the interval between 20 and 40 microns. Find mean, standard deviation and cumulative distribution function of the protective coating. So what is given is the interval as 20 and 40. That means what? A value is 20 and B value is 40. Now based upon this, we'll write down the distribution function first, and since he has mentioned it as uniform distribution, right, so first we'll define the distribution. So what is f of x given by? F of x is equal to 1 by b minus a between interval a less than x less than b, 0 elsewhere. So based on this, what is the function here? The function will be 1 by 40 minus 20. So 1 by 20 between the interval 20 less than x less than 40 and 0 elsewhere. So the uniform distribution function is given by 1 by 20 between limits 20 and 40 and 0 elsewhere. Now from this we have to find the mean, standard deviation and cumulative distribution. So first we'll find out the mean. Now as we already know, mean is given by b plus a by 2 or a plus b by 2. So mean is a plus b by 2 and a is equal to 20, b is equal to 40. So 20 plus 40 by 2, that is 60 by 2 is equal to 30. Mean is given by 30. The thickness of the coating is given by 30. And then we'll find the variance. Variance is given by b minus a whole square by 12. So b minus a whole square by 12 means b minus a, we already know it is 40 minus 20 whole square by 12. So this is equal to 40 minus 20, this 20 square is 400 by 12. So on simplifying, this value will be equal to 100 by 3, and we got variance as 100 by 3. So what will be the standard deviation? We'll take the square root of the variance. So standard deviation is given by under root of variance, which is equal to under root of 100 by 3, which is equal to square root of 100 by 3 is 5.77. So we found mean and we found variance. Now we'll find out the cumulative distribution, right? So we already have discussed what is cumulative distribution function given by cumulative distribution function. Capital F of x is defined by 0 for minus infinity less than x less than a, and this is given by x minus a by b minus a between a less than x less than b. And like discussed in the previous videos when we have discussed continuous random variable, I told you that when we write the cumulative distribution function, the last value will be 1, b less than x less than infinity. Now based on this, we'll write on the cumulative distribution function here, and already we know a value is 20 and b value is 40. So what will the cumulative distribution function? So the cumulative distribution function is given by, is denoted by capital F of x, and is denoted by capital F of x, and is actually given by integral from minus infinity to x f of x dx, right? We can either take this and solve it, or else we'll use directly the form. So this is equal to 0 minus infinity less than x less than a, and we know a value is 20, so less than 20, and x minus a, that is x minus 20 by b minus a, 40 minus 20, so x minus 20 by 20 between limits 20 less than x less than 40 and 1 between limits 40 less than x less than infinity. Or simply we can write x greater than 40, and here also we can write simply x less than 20. We will look into one more example on uniform distribution. So first we will see what is given. Subway trains on a certain line run every half hour between midnight and 6 in the morning. What is the probability that a man entering the station at a random time during this period will have to wait at least 20 minutes? So we have to find out the probability of waiting time is at least 20 minutes, and he has given what the train arrives every half an hour between midnight and 6 in the morning. So first we have to write down what are the values of a and b. So before that I'll define the variable random variable x as, we'll define the random variable x as waiting time in minutes for the next train. And assuming that the man arrives randomly to the station and x is uniformly, and we see that it's given that every half an hour, so x is uniformly distributed in interval x is uniformly distributed in the interval 0, 30. Right, because he has mentioned that every half an hour there will be train, so starting point value time is 0 and ending value is 30. So between 0 and 30, that means what, a is equal to 0 and b is equal to 30, and we know that this 30 should be less than, b value should be less than a, so 30 is obviously less than 0. Now we'll find out what time probability that at least 20 minutes. Before that we'll define the distribution. So the uniform distribution is given by f of x is given by one by b minus a, that is 1 by 30 minus 0 is 1 by 30 between interval 0 less than x less than 30, right, a less than x less than b and 0 remaining. Right. Now we'll find out the probability of x at least waiting at least 20 minutes, right. So probability that the waiting time is at least 20 minutes. So probability of at least 20 minutes, that means we have to find probability of x greater than or equal to 20, right. And since it is a continuous distribution, we can write it as what, this is equal to integral 20 to lower limit is 20, and what will be upper limit? Upper limit will be till 30 is defined as 1 by 30, remaining will be 0. So we'll take the interval from 20 to limits from 20 to 30 f of x dx, and here what is f of x, 1 by 30 which is constant. So I'll take this 1 by 30. So we'll have integral limits from 20 to 30 1 by 30 dx, right. Now 1 by 30 will integrate, 1 by 30 is constant, so we can write this as what, 1 by 30 integral of dx between limits 20 and 30, and we know integral of 1 is x, so 1 by 30 x values between 20 and 30. So now substituting what we have, this is equal to 1 by 30, upper limit is 30 and lower limit is 10. So 30 minus 20 which is equal to 10 by 30, that is 1 by 3. So probability that waiting time is at least 20 minutes is 1 by 3. Thank you.